We live on a sphere nearly 13,000 kilometers in diameter. If you drove a car around the equator at 100 kilometers an hour without stopping, the trip would take 16 days. On a human level, that feels massive. But the scale of our planet evaporates the moment we look at our nearest neighbor. The moon is 384,400 kilometers away. To visualize that distance, look at the gap between our world and theirs. You could fit 30 full-sized Earths side by side in the empty space between us. That car of yours would need 5 months of non-stop driving to reach it. Even the Apollo astronauts, who traveled faster than any humans in history, required 3 days to cross that single gap. Kilometers and hours are useful for cities and continents, but they fail to describe the cosmos. To see further, we have to use a yardstick based on the fastest thing in existence. Light moves at 300,000 kilometers every second. At that speed, it takes 1.3 seconds for a signal to travel from the moon to Earth. Scaling up to the sun, 150 million kilometers away, light makes the journey in 8 minutes and 20 seconds. If the sun vanished right now, we would continue to see its glow for nearly 9 minutes. We will use this light speed ruler to measure the known limits of reality, though we will eventually encounter a measurement that defies a simple calculation of time and distance. In the outer reaches of our solar system, light takes over 4 hours to reach the planet Neptune. Beyond that, the Oort cloud is so vast that light requires 2 full years just to cross it. Our nearest stellar neighbor, Proxima Centauri, is 4.25 light-years away. Even at the speed of light, the journey takes nearly half a decade. Humanity's fastest machine, the Parker Solar Probe, travels at 690,000 kilometers per hour. If we pointed it at that nearest star today, it would spend the next 6,700 years coasting through the void before arriving. Zooming out to the Milky Way, we find 200 billion stars held together in a disk 100,000 light-years wide. If our entire solar system were the size of a single coin, our galaxy would be the size of North America. We live in the galactic suburbs, 27,000 light-years from the center. At this scale, even light speed starts to feel agonizingly slow. Our galaxy is part of the local group, which includes our larger neighbor, Andromeda. It sits 2.5 million light-years away and is currently hurtling toward us for an eventual collision. The local group is just one tiny piece of the Virgo supercluster, a structure spanning 110 million light-years that contains hundreds of galaxy groups. In 2014, we mapped an even larger home, the Laniakea supercluster. It is 520 million light-years wide and contains 100,000 galaxies, all flowing toward a single gravitational point. On this scale, billions of stars are reduced to specks of dust, arranged in an intricate cosmic web that resembles a neural network. Finally, we reach the edge of our vision. Because light takes time to travel, the further we look, the further back in time we see, out to a distance of 46.5 billion light-years in every direction. However, the universe itself is only 13.8 billion years old. This creates a massive discrepancy. If light is the absolute speed limit, a 13.8 billion-year-old universe should only be 27.6 billion light-years across. Instead, we observe a diameter of 93 billion light-years. This gap reveals that our understanding of simple motion through space is insufficient to explain the current size of the universe. The explanation lies in what is actually moving. Galaxies are not flying through space like shrapnel. Instead, the fabric of space itself is stretching. Imagine 2 dots on a rubber band, representing galaxies, with an ant, a photon of light, walking between them. As the ant walks, we stretch the band. Its speed never changes, but the distance grows because the material underneath is expanding. This mechanism bypasses the speed of light. While objects have a strict speed limit when moving through space, there is no limit to how fast space itself can expand. A photon can travel toward us for 13.8 billion years, but because space itself was stretching during that entire journey, the galaxy that sent that light is now 46.5 billion light-years away. This expansion was supercharged by cosmic inflation, a moment after the Big Bang where a region smaller than an atom was stretched larger than a galaxy. This means the edge of the observable universe is a horizon in time, not a physical barrier. The total universe likely extends infinitely beyond what we can ever see. This perspective can make a single human life feel like a rounding error in a nearly infinite void. But the physics of this expansion allowed those 200 billion galaxies to form, creating the environments where stars could forge every atom in your body. The fact that a collection of those atoms, living on a small rock for a brief moment in time, has used science to map the entire history of the cosmos is perhaps the most incredible realization of all.